All right, let's dive into a question that, trips up a lot of people when they're first learning about neural networks. Why on earth are autoencoders considered an unsupervised algorithm? It sounds like a total contradiction, right? But the answer is actually pretty cool and, well, surprisingly elegant. Let's break it down.
So here's the heart of the puzzle. An autoencoder's entire job is just to copy its input. I mean, the correct answer is baked right in. It's the original data you started with. So how can a system with such a clear, obvious target be called unsupervised? It kind of feels like it's cheating the system, doesn't it?
Okay, so first things first, let's just check the official verdict. Is this just, a matter of opinion, or is there a definitive classification we can actually point to?
And here we have it, straight from the source. The course outcome is to elaborate unsupervised deep learning algorithms like autoencoders. Well, there's no ambiguity there. So the verdict is in, they are officially unsupervised. Now let's figure out the why.
To really solve this, we need to go back to basics for a second. Let's break down precisely what an autoencoder is actually trained to do. What is its fundamental job?
So at its core, the goal is surprisingly simple. The network has one and only one mission. Make the output an identical copy of the input. Whatever goes in has to come back out as accurately as possible.
And this slide gives us a perfect example of that. You can see an image of the number 2 goes in on the left. It gets passed through an encoder and then a decoder. And the whole point of this entire process is to reconstruct that exact same 2 on the right side.
Okay, so this brings us right back to our original puzzle. If the network is constantly checking its output against that original 2, isn't that a form of supervision? Well, this is where the really elegant trick of the autoencoder comes into play.
And boom, this one single line from the source material solves the entire mystery. The input, which we call X, is also the target. The data literally becomes its own label.
This comparison here makes it crystal clear. So in traditional supervised learning, you have an input X, say a photo of a cat, and a completely separate human-provided label Y, like the word cat. The goal is to learn how to map X to Y. But with an autoencoder, the input X is used as both the input and the target. It's generating its own supervision, right from the data itself.
And this whole idea, this self-labeling approach, is the absolute key. This is what makes it a fundamentally unsupervised technique.
So, to put it all together, because the autoencoder uses the input as its own target, it needs absolutely no external human-created labels, not a single one. It learns just by observing the raw data. And this process, finding patterns and structure in unlabeled data, is the very definition of unsupervised learning. And that perfectly justifies the statement.
This whole concept of learning through self-reconstruction, it raises a really fascinating question, doesn't it? If a machine can find meaningful patterns just by trying to copy what it sees, what does that suggest about the nature of learning itself? It makes you wonder, what powerful features can a model discover about the world when all it ever learns to do is see itself?